Howdy, PreCal. It is Miss Kosh, and today we're going to look at function operation and composition. And so we begin looking at some different notation. If I say f plus g of x like this, that's how we would read it. This is f plus g of x, or that's like saying f of x plus g of x. So if I think of f of x, I'm going to use the color green, and I'm going to use, I don't like orange. I was about to pick up an orange marker. Let's see if this red one works, but I'm an Aggie. I like maroon. Okay, so, and red is tolerable, but I can't do orange. Okay, so, sorry. So if I have this f plus g of x, or I might say f of x plus g of x, sorry about the notation, this would be equal to, well, the f equation is x squared plus 1, the g equation is plus 3x minus 2, and now I just need to combine like terms. So I see, I see 1x squared, I see this regular x, and I see 1 minus 2 is negative 1. Are there any restrictions to the domain? Well, the two things that give us restrictions are dividing by 0 and trying to take the square root of a negative. I see no square roots, and I see nothing dividing. So there are no restrictions, so I might say none. So the domain is all real, which is negative infinity to positive infinity. The next one, we're looking at f of x minus g of x, or this is f minus g of x is how we read that one, f of x minus g of x. On this one, it's a little trickier. There's a little more room to mess up, because back here, I could have put a parentheses here, and when you distribute a positive 1 through here, nothing changed. Okay, so everything was great. However, here, when I write down f was x squared plus 1, I now need to make sure, don't forget, I keep my parentheses for this 3x minus 2. Okay, so now we need to distribute. We have x squared plus 1. This becomes a negative 3x and a positive 2. So now, I'm having fun with colors. These are all equivalent. Okay, this will be equal to, I see an x squared, I see a negative 3x, and a 1 plus 2 is 3. Once again, I'm not dividing by anything, so I'm not dividing by a variable, so we don't need to worry about that. That's my Chuck Norris joke. Chuck Norris can divide by 0, you can't. But we're not trying to divide, so that's fine, and I don't see any square roots. So my restrictions, I have no restrictions, and so my domain is negative infinity to positive infinity. Okay, the next one, this we would say f times g of x. So they're multiplying here, or f of x times g of x, like this. So f, okay, equals f was x squared plus 1. Here comes g in a different color, 3x minus 2. And now with this, I have a binomial times a binomial I have to FOIL. So I see an x squared times a 3x, that gives me 3x cubed. I see an x squared times a negative 2, that's a negative 2x squared. I see a 3x times 1, which is a positive 3x, and I see a 1 times a negative 2 is a negative 2. And now I don't have any like terms. There is nothing to combine. So this is my final answer here, and my restrictions. Once again, I'm not trying to divide by 0, and I'm not trying to take the square root of a negative, so there are no restrictions. And so my domain is all real numbers, or negative infinity to positive infinity. Okay, the next one, oh funny, I don't know why there's a dot there. There shouldn't be, ignore that. The next one we would say f divided by g of x, or f over g of x, so f of x divided by g of x. We just have to make sure, we're not Chuck Norris, we can't let the denominator equal 0, so our function of g of x cannot be equal to 0. So that means f was this, x squared plus 1, and it's being divided by 3x minus 2, and there's nothing we can do to clean this up. There's nothing that factors out of the top and it'll cancel. Keep in mind, if I have something like x squared plus 4 over x plus 4, you can't cancel the 4s. You can't just, so try this. Say I had, let's say 9 plus 4 divided by, well, notice I picked a perfect square. I did this on purpose. 3 plus 4. If I just said, oh, let's cancel these out. This is 9 over 3, which is 3. No. This is 13 over 7, which is not the same thing. Okay, so we can only cancel when things are being multiplied, not when they're being added. Okay, so this is our answer. There's not any way to clean this up, but we do have restrictions. And our restrictions are we can't let the denominator 3x minus 2 equal 0. So I'm going to add 2, and I'm going to say 3x cannot equal 2. And I'm going to divide by 3, and I'm going to say, okay, my restriction is that x cannot equal 2/3. Okay, so my domain, it's the set of everything except 2/3. Or we could say from negative infinity to 2/3, pick it up again on the other side of 2/3 and go to infinity. We're using soft brackets because it's everything in the whole wide world except 2/3. Okay, let's keep going. Now we're looking at, so these were operations. Now we're on to composition. This looks kind of like fog or golf, but it's not. What this means, and sometimes it's helpful to write this out. This is saying f of what? F of g of x. Okay, I'm staying with the colors. Oh, we have new F's and G's, but I'm going to keep F green and G red. Okay, so this is saying anywhere we had an x in F, we're now plugging in the whole function g of x. Okay, this other one, so when it looks like this, what I would do, I would not even try and work with this. I would say, oh, this means g of f of x. I'm just having fun with color, I'm sorry. Okay, and I would write this out, and I'm like, okay, now I know what I'm doing. Okay, so let's look at these first couple here. This first one is saying f of, well, g of -1. Okay, so let's see, what is g of -1? I need to come over here to g. Let's do that in red. G of -1 would be equal to 3 times -1 squared. Anywhere I saw an x before, I'm now putting in a -1. A negative times a negative is a positive, so this is equal to 3 times 1 is just 3. And so now I found that g of -1 is equal to 3, so I can rewrite this as f of 3. Okay, and now what's f? Well, f, this would be equal to something plus 4. Well, that's something we're plugging in, and what used to be an x is now a 3. 3 plus 4 is equal to 7. So g of, I lied, f of g of -1 is equal to 7. Okay, the next one, let's see, how does that compare to this other one? This one would be like saying g of f of 1. Okay, using color. So what is f of 1? F of 1, so f of x was equal to x plus 4. So f of 1 means I say wherever I had an x, I'm now putting in a 1. 1 plus 4 is equal to 5. So this becomes g of, I want to parentheses, g of what? G of 5. See how f of 1 is equal to 5? And then g, okay, so what is g equal to? G is 3 times something squared. Well, that something used to be an x, now we're putting in a 5. 5 squared is 25. 3 times 25, if I have 3/4, I have 75 cents. And there we go. Okay, so now the next one, I'm really going to enjoy the color on this one. So this is saying, excuse me, this could also be written f of g like this, of x. So we're going to take the function f, which is something plus 4, and what we're going to put in is we're going to put in g. Well, g over here is this 3x squared. Well, we don't need the parentheses. We just have these two terms. And so this cleans up to be 3x squared plus 4. And there we go. Oh, any restrictions? Okay, we didn't have restrictions on these two because we just got answers. This one, I'm not trying to divide by a variable, so we're good to go. I don't see any square roots. Okay, the next one, I have g is 3 times something squared. We're putting in f for that something. And so that is x plus 4. So when I have x plus 4 squared, be careful that you don't just say x squared plus 4 squared because there's a middle term. So a quick little reminder, it's x plus 4 times x plus 4. You could do this and say, okay, this is an x squared. This becomes a 4x, that becomes a 4x, so plus of 1 4x plus a second 4x, and then plus a 16. This gives me x squared plus 8x plus 16. Or you might recognize, okay, so where am I? I was at 3 times what? Well, now we've cleaned this whole thing up to be x squared plus 8x plus 16. I didn't save myself enough space, but there we go. Or you might recognize the fact that anytime I have an a plus b and I square it, it ends up giving me a squared plus 2ab plus b squared. So when I had this x plus 4, and I squared it. If I were you, I would go home and write this on a dry erase marker on my bathroom mirror so I see it all the time. And actually, you can put a minus here, and then it puts a minus here. If this is a minus b, it'll make this one negative, but it keeps that one. That one still is positive. So, a squared, so a is x now, so it's x squared. Multiply these two, that's 4x, and then double it. 4 doubled is 8x. 4 squared is 16. So that's another way to get to the same place. And let's go ahead and clean this up. Let's distribute that through. I see a 3x squared. 3 times 8 is 24x. 3 times 16, 48. And there we go. Okay, how long is my video? Oh, let's keep going. Okay, so find the following functions. We're going to do some similar operation stuff. Okay, maybe I'll finish these 2 pages, do odd and even in another video. So sorry. Okay, I had to come up with a game plan. So on this one, g of 2, well, g of 2 would be can you see that this matches g? Well, so g of 2, so it's something squared over something minus 1. So we're going to plug in a 2 here and a 2 here. I can come along and subtract. Well, I need a parenthesis since I'm subtracting all of this. It's something squared plus 1. See how that matches this? We have an x squared plus 1, something squared plus 1. So that's something, they told me to make it negative 2. Okay. 2 squared is 4. 2 minus 1 is 1. Okay, 4 divided by 1 is still just 4, so there we go, that's ready to go. Minus, I see a negative times a negative is a positive, so this becomes a positive 4 plus 1. So this becomes 4 minus, I see a 5, and your final answer is negative 1. Cool, okay. The next one, this is saying f plus g of negative 3. So this is like saying f of negative 3 plus g of negative 3. Okay, so f of negative 3 means I have something squared plus 1, plus, and then g would be something squared over something. Oh, that's a parenthesis. I was about to write an x. Could you tell? I'm so sorry. It is Friday at almost 4 o'clock in the last day of the first week of school, so I'm tired. But here we go. We're great. This is a negative 3, and what am I plugging in here? Also a negative 3. So I have negative 3s and all. Oh, I don't know why I used blue or green. Oh my, okay. I see a 9 plus 1 plus a 9 over negative 3, and a negative 1 is a negative 4. Well, that's kind of annoying. Okay, so I see 10 plus 9 over negative 4. I would let you grab a calculator and figure out what to do here. I'm too lazy to go find my calculator. Let's make this 10 would be a 40 over 4. This minus a 9 over 4, so this would equal 31 over 4, which is what decimal? 7.25? No, 7.775. Anyway, check with your calculator, see if I'm right. If I'm not right, tell me nicely in the comments. I'm good, but I'm not perfect. Okay, so on this one, we have f of x is being divided by g of x. Well, this is kind of annoying because I have a fraction and a fraction. And in general, we don't want to leave a fraction and a fraction. It's a bad idea. So maybe let's write it this way. Let's say our f of x is being divided by g of x. Actually, this is wrong as it's written. This needs a parenthesis. That whole thing was being divided by this whole thing. Okay, well, how do you divide fractions? Have you heard the expression keep, change, flip? We change this to multiplication, and we flip this over. So I have an x squared plus 1, in parentheses, times, now I have an x minus 1 over x squared. Okay. I'm not quite sure. I should ask my colleague how far we expect you to go. Right now, I see in the numerator an x squared plus 1 times an x minus 1 all over x squared. It could be that that's fine. Let me keep going. Let me FOIL this out in case we need you to go farther. I'll try and ask her and talk to you later. So I see an x squared times x is x cubed. I see x squared times negative 1 is negative x squared. I see a positive x, and I see a negative 1, and everybody's divided by x squared. Does this have any restrictions? Yes, it does. You are not Chuck Norris. You can't divide by 0. So this x squared cannot equal 0. Well, the square root, if I take the square root plus minus, square root of 0 is just 0. So x cannot equal 0. So here is our answer with our restriction. Super. Okay, now I have f of g of negative 1, I don't know why I rewrote what was already there. G of negative 1, let's come over here. We'll just do g of negative 1 equals negative 1 squared over negative 1 minus 1. Negative times negative is a positive. A negative and a negative is a negative. I have a positive 1 over a negative 2. So this is a negative, g of negative 1 is negative 1/2. So this will be equal to f of negative 1/2. Oh, for symmetry, that's green, pretend. Okay, f was what? Something squared plus 1. Could you see it up there? That something is a negative 1/2 squared plus 1. When I square a negative times a negative is a positive, this becomes a 1/4 because 1 squared is 1, 2 squared is 4. 1/4 plus 1. Well, 1, it would also be known as 4 over 4. But I don't know. Anyway, and so this is equal to 5/4. Okay. I'm getting a little tired of this. Sorry. Okay, let's do, maybe I'll go f is 3 times something minus 3. The g is equal to 1 over x. And so I end up with 3 times 1 over x. This is 3 over x minus 3. We could get a common denominator, but I don't feel like we need to. So I think we're good. On this one, though, what are my restrictions? You are not Chuck Norris. You cannot divide by 0. So x cannot equal, the denominator cannot equal 0. G of f of x, g is equal to 1 over something. What was the something? The something, this x, I'm now replacing and putting this in, 3x minus 3. And actually, I'm done. There's nothing I can do to clean this up. So let's say 3x minus 3 cannot equal 0. I'm going to add 3. I'm going to divide by 3. And so, oh, I'm sorry, I lost my not equal. X cannot equal to 1. So my domain would be negative infinity to 1. Pick it up again on the other side of 1 and go to positive infinity. Okay? F of 4. All right. So, well, let's just say, okay, f of the first 4. F of 4 is going to be 3 times 4 minus 3. So I took out the x and put in a 4. I see 12 minus 3 is 9. And so now this becomes, well, this was f of 4. And now I have f of 9. So now we're going to come along and say, okay, well, this is equal to 3 times whatever minus 3. That whatever is now 9. 3 times 9 is 27. Minus 3 is 24. Okay, this is g of 4. And notice I do find it helpful to, anyway, that now I've just made a mess. I find it helpful to rewrite this to look like this. So g of 4 is equal to, 1 over 4. And so there we go with that. We have g of 1/4. And so this becomes 1 over 1/4, which is the reciprocal of that. That gives me, that equals 4. And there we go. I'll make another video for the evens and odds. All right, like, subscribe, comment, all the things. Go practice.